Hey, welcome to a walkthrough of this post. Today's story. What happens when you fail to build the same product 5 times, then finally figure out why? Stop building tools. Start building a workbench. The pattern that haunted me. I tried to build the same thing 5 times, 5 different attempts, all slightly different framings, all ending stuck. Each time I thought it was a technical problem, it wasn't. The lesson that finally landed. If you have tried to build the same thing 5 times and failed 5 times, you probably do not have a technical problem. You have a framing problem. The 5 false starts. Storyline decompiler lost in reverse engineering. iSpring analyzer tool specific only, didn't generalize. Scorm to XAPI converter solved the wrong problem. Then 4 PHP analyzers, copy pasting the same logic. And finally, an AI powered version, expensive, non deterministic, unnecessary. The breakthrough wasn't a technical insight, it was a product insight. Build the workbench, not the wrench. Stop building tool specific analyzers. Build a universal workbench that treats every course the same way through a common intermediate representation. What Course Workbench actually does: 3 things. Import any SCORM zip or folder, analyze it with a deterministic engine that identifies the authoring tool, parses the structure, and maps the tracking model, and preview the course in a mock SCORM API without an LMS. The engine is deterministic, no AI required, pattern matching using file signatures and directory structures, storyline leaves story content slash, rise leaves SCORM content slash, Captivate has its own signature. 7 tools, all detectable in milliseconds. The unifying abstraction. Course IR, a universal intermediate representation. Every course, regardless of authoring tool, normalizes into this common structure. Once you have Course IR, every downstream feature works for every tool. Architecture you can build on. A subtle bug that took real debugging. The mock SCORM API. Some courses declare var API equals null in their initialization, which silently overwrote the injected mock. No errors. Tracking just didn't work. The fix: object.define property with writable false. Make the API non-overwritable. Lesson buried in that bug: defend your globals with object.define property. When you're injecting things into a global scope and untrusted code shares that scope, protect them. Writable false makes overwrites silently fail rather than silently break you. Another trap: static export. Next.gc static export breaks API routes. Node_env check is unreliable during builds. The fix: a custom environment variable plus a build script that conditionally removes and restores dev-only routes. Build time gymnastics. Tech stack next.js16. Hero UI for components, Stand for state, TypeScript everywhere, and a cross-platform deploy strategy, Tauri for desktop, Capacitor for mobile, web is the default. Write once, ship everywhere. 2 sessions to MVP. Session 1, detection engine, manifest parser, the 8-section UI, and library import. Session 2, the mock SCORM API, file serving, the iframe viewer, static export, and the tracking viewer. Tested against a real hand-coded SCORM tutorial. What the previous PHP attempt got wrong. Rescorm had 7 analyzers. All of them copy-pasted storyline detectors. They returned the same data regardless of input. The lack of a unifying abstraction meant every new tool meant a new copy-paste. Course IR fixes that at the architecture level. 5 lessons. Products beat tools. Intermediate representations unlock flexibility. Deterministic beats probabilistic for structured data. Defend your globals with object.define property, and failed attempts inform the final architecture. They're not wasted. Try it yourself. Build a SCORM manifest parser. Use fast XML parser. Load the ims manifest.xml. Detect the SCORM version. Match file signatures to identify the authoring tool. Extract the launch URL. That's the foundation. Everything else builds on it. What's next? Batch analysis. Run many courses through the workbench. Comparison mode. Diff 2 courses side by side. Export reports for documentation. Plug in architecture so others can add tool detectors. And SCORM 2004. Sequencing visualization. The takeaway: The breakthrough wasn't a technical insight, it was a product insight. Five failures meant the framing was wrong, Workbench beat Wrench, two sessions surpassed years. If you've failed at the same idea repeatedly, ask yourself, what's the framing? Eli at actira.com. Cheers.